All right. Good morning. We only have 10 minutes, so I'm going to go through this pretty quickly. I'm Austin Federa. I'm one of the 3 co-founders of the DoubleZero project. We are building a high-performance fiber network for distributed systems. So this is net new base layer infrastructure, which is a thing I want to kind of hit on a bunch here, because DoubleZero is a physical fiber infrastructure network for high-performance distributed systems. And when we mean physical fiber, we mean fiber in the ground. We're not talking about software overlay systems. We're not talking about VPNs that run over the public internet. We're talking about physical fiber in the ground. And the idea here is to build an alternative pathway for consensus, state propagation, and all these other things that blockchains have to do. One of the things, as you may have realized from the Hyperliquid talk, is they're all basically in the same data centers in Tokyo. And there's a reason for that. It's really efficient to do high-frequency communication and move data very quickly when you're running inside of a single data center or several data centers that are all connected. The minute you start to move data across the world, the public internet's actually not very good for this. And you see this on Solana all the time, where it's actually very hard to propagate the state necessary to vote on all the transactions to keep the blocks moving quickly with a 2,000 validator set node system. It's part of why all of the alternatives today are 1/10 to 1/20th of the number of actual nodes in the system. So I think the trilemma was a nice framing technique in 2017, but it hasn't really been accurate for a while. And really what we're trying to do with DoubleZero is make it so you can run a very fast, very performant blockchain without having to go down to a very small amount of node count to make that possible. So here's my 2 co-founders. They have lots of experience in the high-performance networking world and high-frequency trading world, having built physical fiber infrastructure for companies like Jump Trading, as well as actually Matteo ran a carrier that serviced high-frequency trading firms all over the world, specializing in Latin America. So this is the problem with the internet today. What you see here, oh yeah, the laser pointer does work. Look at that. So what you see here today is the orange and yellow are 2 different public internet connections. This is round trip time from LA to Singapore on 2 different providers. And the blue that you see down below is the round trip time from Singapore to Los Angeles on the DoubleZero network. And there's 2 things to notice here. One is it's faster, right? We like lower latency connections. That's good for everybody, but it's extremely consistent across time. And the public internet has this property called jitter. And jitter is a measurement of the average difference between ping times, which are measures of latency across the internet. So what you see here is you start off pretty good, and then, around the middle of the day, you see that whatever internet service provider we were using for data tracking here actually switched the cable. The fundamental physical infrastructure, the pathway that your data moves, changed. And that change was pretty dramatic, right? We're going up to 350 milliseconds from about 250 milliseconds. If you're running a network like Solana, where you have 400 millisecond block times, that is all of your time, right? And many of these points are actually exceeding what's allowable in a block time. And so this is why when you start to see networks claiming things like 10 millisecond latency or something like that, it doesn't really reflect, that may be true for their internal matching system, their internal blockchain, but that doesn't attach to the problem of how users actually interface with this stuff, because the network is limited by the connectivity. We have passed the point now where compute is a limiting factor in scaling blockchain. All of the problems that we're dealing with are network connectivity layer. And so our whole thesis was, you can't solve this with overlay networks. You can't solve this on the validator client software side. You really have to start looking at physical infrastructure. This is basically the model here, right? So this is a rough chart equating blockchains to the OSI model in computer science. And pretty much everything we've done since Bitcoin is layer 5 and above. There's almost nothing that deals with low-level infrastructure when you're talking about this. If you're running a validator in a high-performance data center, it is still talking over the public internet. It is still subject to all of the problems of the public internet. And even though a data center has faster connection to, let's say, the broader network than a home internet connection does, it faces the exact same problems of high jitter, high latency, indeterminate routing the minute you start to cross outside of that data center and go into the public internet. So what are we doing to solve this problem? Well, DoubleZero has 2 main components to its architecture. It's comprised of a global dedicated network of physical fiber. And so this is, again, physical cables of fiber or wavelengths of light running across those. And the second is a hardware accelerated filtration and defense system for networks, which run on FPGAs. This is kind of the architecture that we go through. You can find this all in DoubleZero.xyz. We have a whole white paper that goes into detail on this. And so what we basically see here is executed blocks in the center. This is sort of your protected area in the middle. You see external filtration devices for things coming in through the internet. We'll go through a little bit of what that looks like. The TVs are turning off for who's ever running this. So I'm about to lose all my slides and my timer. So if someone wants to fix that, that would be awesome. This is what the DoubleZero fiber network looks like today. So we have a testnet up and running, which is a subset of this. This is a version of what the mainnet deployment is going to look like. We have most of this installed at this point, and this is made up from 6 independent network contributors. So that includes 2 trading firms, 2 VCs, and 2 bare metal providers that are contributing physical fiber into this system. And so one of the things that we're doing is we're looking for more contributors who are folks who run networks or folks who are bare metal providers and are interested in bringing DoubleZero into their data centers and places that they operate. This will be live in Q3. This one we're looking to go to mainnet. Today we have approximately 30 Solana validators running on our testnet, but we're supporting all sorts of high-performance distributed systems, not just Solana, not just blockchain. We think that really one of the main problems today is when anyone tries to build a distributed system, they're either suffering a massive time penalty or they are suffering the problem of not being able to, of having to build these types of things on top of the existing infrastructure. And so you're playing against Microsoft and Google and Amazon's game when you're having to build systems on top of them to try and compete with them. We think there's a better alternative. So this is a high-level overview of how this works. At the core of it, we are using industry network standard technologies. On top of it, what we've basically built is a distributed system to manage centralized networks. And this is really cool. So private high-performance networks exist. Jump Trading runs one, Citadel runs one, Google runs one, Amazon runs one, but they're all managed and they have all admin keys by one individual company. And the real breakthrough with DoubleZero is we can use that technology that has only been accessible in the private world through fully centralized networks to basically take this and apply it to blockchain and do it while we still have crypto economic security, while we still have all these principles of multiple independent contributors that folks know and love in the space. Additionally, these networks are designed in ways that you can, of course, fall back to the public internet. So if there is a problem with DoubleZero, your validator can switch back over to using the public internet. The network may need to scale down its transactions per second count then to hit the public internet, but we do have the idea of safe modes you can build into these types of systems. The slides got very zoomed in. Okay, so we'll set this aside for a minute because the slides aren't working. I've only got a few more minutes left, but FPGAs are one of the main pieces of technology we're bringing to these network systems. And so field programmable gate arrays pretty much allow you to accelerate things in hardware that are common software applications without having to build ASICs specifically designed for those systems. All right, it's getting fun. And so one of the cool things about FPGAs is they're very fast at doing very simple tasks. And so we're able to do things like take signature verification, which is something every validator has to do before it processes a block, and we're able to do that in hardware. And so we can signature verify 100 gigabits per second of line rate transaction data coming into one of these systems, which offloads an incredible amount of work from the validator. At the same time, we can do things like dedupe duplicate packets that are coming in. So if you're getting spammed with 40 gigabits per second of identical data, the network will drop that data as well, which is pretty awesome to see. And we could have multiple validators downstream of these filtration devices. And so this can be sort of a shared defense layer on top of a lot of these different types of systems. One of the cool things is it's what's called a bump in the wire design. So it adds functionally zero latency to the operation of these systems. And we can do cool things like implement QoS in the future as well. So you could say, if state propagations and votes always receive higher priority than transaction data if your goal is to make sure the network continues to stay up in a situation where it's getting flooded with more data requests than it can handle. And the last thing I think I have time to talk about today is multicast. And so multicast is a really cool technology that's been used in trading firms for decades at this point, which basically is a hardware acceleration of packet replication. And so you can send one bit of data through the network, and the switches will automatically replicate that data and get it to everywhere else it needs to go in the network. This is not what happens today. Any high-performance blockchain today, whether it's Solana or Aptos or Sui or anything like that, it's using some form of software system on the validator to send that data out. So on Solana, you create a block, and then you send it out to 200 nodes, and those send it out to 200 more, and those send it out to 200 more. And eventually, you get the data all throughout the system. This is called Turbine. On Mana, they have a similar system called RaptorCast. The challenge with these systems are they require huge amounts of bandwidth at the validator level, and it takes a lot of time because the validator has to send all that data out itself. And so if we can move this over to technologies like multicast, it massively reduces the operational and bandwidth load on an individual validator, and it allows data to move much more efficiently through the system. This is kind of back to that core thesis of the limiting factor today for these systems is not actually the validator clients themselves, right? Solana's built a validator client that can do 1 million transactions per second. Aptos has benchmarked their client at several 100,000 transactions per second. Sui is the same way. Mana is the same way. Most of these new systems are not compute limited. What they're limited by is how quickly they can reach consensus in a decentralized architecture in a decentralized world. And that's the main thing that we are looking to solve. So I'm going to skip through a few of these things. You can learn more about DoubleZero at doublezero.xyz, which is our website, docs.malbeclabs.com. Malbec Labs is one of our core contributor entities, has a lot of information on how to connect, and hello at doublezero.xyz will get to us as well. Our testnet is up and running. We'd love to talk to folks at protocols that are interested in trying this out. We have built out support for Solana at the moment, and are building out support for other systems as well. And if you or know someone who runs a fiber network and they're interested in participating in the DoubleZero network, we are a token incentivized network, would love to chat. Thanks again.